for question number 2, a polygon of constraints is shown in the graph below. The rule of the optimizing function is c is equal to 2x plus 3y, and the objective is to maximize. Identify the systems of inequalities whose solution sets are represented graphically. I'm going to start with a, b. I'm just going to do it alphabetical. A to b. The b value, we don't know what it is. B, we don't know. We can't read it off the graph. We're going to have to calculate it using our points. The delta y over delta x, I am moving over 1, 2, 3, 4, 5. Delta x is 5. And then we're moving down 1, 2, 3. So delta y is negative 3. We're shading above it. Y is greater than or equal to negative 3 over 5x plus some b value. I'm sure about the point 60. I'm also sure about the point 13. If I do 13, so the y value is 3, the x value is 1. 3 is equal to negative 3 over 5 times 1 is 3 over 5 plus b. I'm going to add 3/5 to both sides. We have 3 and 3/5 is equal to b. 15 plus 3 is 18 over 5 is equal to b, which gives us 3.6 is the b value. Our inequality is y is greater than or equal to negative 3 over 5 x plus 3.6, or 18/5 if you like. That's my line AB. BC. We can read the b. The b is negative 8. b equals negative 8. The slope, the delta x, is 1, 2, 3. Delta x equals 3, and then going up to c, we're going up 4. Delta y equals positive 4. For line BC, I'm saying that y is, we're shading above it, so it's greater than or equal to, it's a solid line. The slope is 4 over 3. X plus the b value is minus 8. Okay, CD, it's a vertical line. Its x is equal to some constant is the equation of a line, but because we're shading this way, its x is less than or equal to, where it crosses the x-axis, 9. For DE, the b value, we can read it right off of here, is 10. We have y, we're shading below, is less than or equal to, it's a solid line. The delta x is, we're moving over from, the delta x is 9, then we're moving down to delta y is negative 2. It's negative 2 over 9. Negative 2 over 9x plus 10 is DE. The last one, the dotted line, we're shading above the dotted line, so it's going to be y is greater than. We're talking about A to E. Y is greater than. The slope is, we move over 1, and we move down from 10 to 3, down 7. The delta y is negative 7. The delta x is 1. It is negative 7 over 1, x plus the b value, which is 10. There are my 5 inequalities. Find the point or points whose coordinates generate the function's optimal value. I need to know all of these vertices. So starting with A, I have 1, 3. B is 6, 0. C is 9, 4. D is 9, 8. E is 0, 10. I'm going to plug all of those into a spreadsheet and do my calculations like that. I have points A, B, C, D, and E, x values, y values. The maximizing function C is equal to 2 times the x values plus 3 times the y values. Starting with A is at 1, 3. B is 6, 0. C is 9, 4. D is 9, 8. E is 0, 10. Let's fill that down. We get all these different values, and notice that 42 is the largest value. D is giving us 42. D point is giving us 42, which is our maximum. Okay, so this is our maximum. Find the point or points whose coordinates generate the function's optimal value. D, which is 9, 8, produces a maximum of 42. Calculate the optimal value is 42. All right, and that's it for question number 2. Have a good day.